Alright, for today's lesson we're going to start with a background skill that you may not have to use nearly as much. It's another form of solving quadratics called completing the square. To be able to complete the square, we need to rewrite, if needed, from standard form to ax squared plus bx equals c form. What that ends up meaning is we get the variables on one side and the constants on the other, and then we can begin to work. So in our example number 1 here, that means that I would have to subtract 5 from both sides to get it with variables on one side. X squared plus 8x is equal to negative 5. Okay. I've left a space there because in completing the square we're going to add something into it. We need to make a equal to 1. Well, of course this was written in ax squared plus bx plus c form, which was the standard form. So the a refers to the coefficient in front of the x squared term. We don't see a coefficient there, so we know it's equal to 1, so we've already got step 2 done. Step 3 says to divide b by 2 and then square it. So b is equal to 8 divided by 2 equals 4 squared is equal to 16. We're going to add 16 to both sides. So plus 16 here and plus 16 here. Now we have a factorable trinomial on one side and we'll have a constant on the other side. So we have x plus 4 squared. Okay, this is the binomial theorem. It says that if we have a perfect square trinomial, which begins with a perfect square and ends with a perfect square, and that the middle term is twice the square root of the constant term, we can write it in just one form. X plus 4 is equal to, x plus 4 squared is equal to, in this case, 11. Okay? Because when we expand this out, 4 plus 4 is 8. All right, now we have a square root equal to a number, so we simply take the square root of both sides. We have a square equal to a number, take the square root. That gives us x plus 4 is equal to positive or negative square root of 11. But we're not quite done yet. We still have to get the x completely by itself, so we subtract 4 from both sides. That gives us that x is equal to negative 4, keeping the whole number first, plus or minus the square root of 11, which is an irrational number and cannot be written any simpler. So this is our solution, and it shows how to go through all of the steps. Okay, we applied the same idea to our next problem. It is already written in the ax squared plus bx equals c form. So we go to number 2. We now need to make a equal 1. A is currently equal to 2, so we make it equal to 1 by dividing everything out here by 2. Once we do that, we have x squared minus 2x is equal to negative 3. Now we follow the same steps that we did up here. We take b, which is equal to negative 2. We divide that by 2, which gives us negative 1, and we square negative 1 to end up with positive 1. So we are going to add 1 to both sides. Once we do that, we have a factorable trinomial, it is x minus 1 quantity squared. Please notice that in the pattern here, we end up with the sign was positive here, we kept the positive. The sign was negative here, we kept the negative. So in this perfect square trinomial, the last term is added. The middle term gives us the term that will go, the middle term gives us the sign that will go into the binomial. And -3 plus 1 gives us -2. I take the square root of both sides, and I end up with x minus 1 is equal to plus or minus the square root of 2. I add 1 to both sides. That then gives me that x is equal to 1 plus or minus the square root of 2. That cannot be simplified any further, so that is my final answer. You may want to pause the video at this point and make sure that you get all of these notes down and all of these example problems down. You will see them on the test at the end of next week, but they will be, for completing the square, it'll be a bonus. I mainly use it as a way of introducing our lesson on the quadratic formula. There is a separate video posted in the Canvas to be able to see completely how the completing the square becomes part of the quadratic equation. So moving right along, we are going to talk about the quadratic formula. The quadratic formula can be used to solve any quadratic equation. There are only 3 steps to have to remember. Set the equation equal to 0. Identify parts A, B, and C in the standard form of the equation. Substitute that A, that B, and that C in and simplify. This is the formula that you would need to remember for next week's test. I will have this on the paper so that you'll be able to use it. So let's jump right in and see how we use this formula. This equation is already in standard form, so I simply identify that A is equal to 1, B is equal to -9, and C is equal to 27. I use my formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So that means that x is equal to -b is negative of the -9 plus or minus the square root of -9 squared minus 4 times a times c. Okay. And that is all over 2 times a, which is 2 times 1. This can be simplified. The negative of a -9 is +9 plus or minus the square root of 81 minus 108 gives us -27 all over 2. Okay, we've worked before on simplifying radicals and complex numbers. We recognize that the negative under the radical means that we will have a complex number. So this is 9 plus or minus 9 times 3 gives us 27. 9 is a perfect square, so I pull its square root of 3 out and keep the regular square root of 3 because it is an irrational number, and keep the 2. So x is equal to 9 plus or minus 3 square roots of 3 over 2, and I forgot my I because that negative has to come out as the I. Okay? On this one, we identify our parts. A is equal to 2, B is equal to 6, and C is equal to 3. Now that we have those, we begin substituting into the formula. Minus B plus or minus the square root of B squared minus 4AC all over 2A. We simplify that. Minus 6 plus or minus the square root of 36 minus 24 gives us 12 all over 4. Square root of 12 can be simplified as the square root of 3 times the square root of 2, square root of 4. The square root of 4 is 2, so I've got 6 plus or minus 2 square roots of 3 over 4. 6 is even, 2 is even, 4 is even, so 2 goes into all of them. Negative 3 plus or minus 1 square root of 3 over 4 is the final, most simplified answer. Okay. On this one, it is not in standard form, so we must make it be in standard form. So we have 3x squared minus 4x, and we've subtracted the 9 from both sides to put it into standard form. Minus 9 is equal to 0. Now we can identify A is equal to 3, B is equal to negative 4, and C is equal to negative 9. Now we plug into our formula. Minus B gives me positive 4 plus or minus the square root of B squared is 16 minus 4 times AC, 4 times negative 27. Is 108, but it is a negative 108. Subtracting a negative is the same as adding a positive. So I've got plus 108 all over 2A, so that is 6. This can be simplified. We add 16. That gives me 4, 2, 1. So x is equal to 4 plus or minus the square root of 124 all over 6. 124 can divide into 124 divided by 16. No. 124 divided by 4. Okay. 124 divides into the square root of 4 times the square root of 31, which this is a perfect square, this is not. So x is equal to 4 plus or minus the square root, I apologize, 2 square roots, because the square root of 4 is 2, of 31 all over 6. 4, 2, and 6 are all even numbers, so it becomes 2 plus or minus the square root of 31 all over 3. That is our final answer right there. All right, for number 4, I'm going to let you pause the video and then try it on your own. Come back in just a few moments to be able to get the answer. Okay, so there is the answer for number 4. I hope that you were able to get 1 plus or minus 2 square roots of 5 over 3. Here's the work that I did to identify that. And it does point out that I have a negative and I forgot to put my I, so I need to do that there. Now it is a complete answer. So I can go ahead to the next problem. On the next problem, it is not in standard form, so start out by putting it in standard form, and the variable should be in decreasing power. Pause the video and try again now. Sometimes when we work out the quadratic equation, we end up with a perfect square under the radical, and when we take that perfect square, we just add or subtract it to the negative b that we had in front, and it leaves us with a nice rational number and two rational answers. So be sure that you understand and can work this out all the way to get that x is equal to 2.5 or x is equal to -1/3. Let's go ahead and just work this last one together. A is equal to 4, B is equal to 12, and C is equal to 9. X is equal to minus B plus or minus the square root of B squared minus 4AC. 4 times 4 is 16. 16 times 9 is also 144. All over 2A, which gives me 8. 144 minus 144 gives me 0. The square root of 0 is 0, so that leaves me with just 12 over 8. -12 over 8 is the only answer for that problem. The last little part of this lesson, we're going to learn about the discriminant. The discriminant of a quadratic equation in the form ax squared plus bx plus c equals 0 is the value of the radicand. Radicand means what is under the radical sign. And the radical sign is just that. The value of the discriminant tells us whether we have one solution or two solutions, and it tells us whether it is complex, real, or, well, there's not an or, something else. So if the discriminant is greater than 0, and we can look back at the front of the page and see that this happens every time, discriminant, the part under the radical, is greater than 0, so a positive number, we end up with two real roots. And even if it still has a radical, it is still a real number. It's only not a real number if you end up with an I. If the discriminant is equal to 0, we ended up with one real root. What happens in that case is that the parabola goes down and it touches the x-axis, but it does not cross it. And if we have a negative discriminant, we're going to have two roots still, but they are going to be complex numbers. Okay, so let's try this out and see how quickly and easily it goes, because it doesn't take long at all to be able to see how this works. All right, the discriminant is simply the part under the radical, so it is the b squared minus 4ac. So we take b, which is 8. B is equal to 8 is what I needed. A is equal to 16, and C is equal to 1. We plug it in. 8 squared is 64 minus 4 times 16 times 1. That gives me 64 minus 64, which is going to be equal to 0. that means that I have one real root. Okay, on this one, b is equal to -5, a is equal to 2, and c is equal to 6. b squared, 25, minus 4 times ac, 2 times 6. 2 times 6 is 12. 12 times 4 is 48. So this is a negative number. We don't have to figure out exactly what it is. We know that it's negative, so we can put that it has 2 complex roots. Last but not least, a is equal to 2, b is equal to -7, and c is equal to -3. As we plug it in, b squared is 49 minus 4 times a times c. With c having a negative in there, that's going to turn it into a negative. Subtracting a negative is the same as adding a positive. 49, and that's 8 times 3 is 24. So that's a positive number. And that means that we have 2 real roots. All right, take a moment, pause the video, record those answers on your sheet. Meet me back to go over the do you understand and do you know how. These will be what I end up looking at for your grade for the participation in this lesson. You'll have open-ended questions for 1, 2, and 3, 3 being the most important, and then 5 and 6. Okay, so open-ended questions on Edpuzzle for this, and I'll make these multiple choice.